Okay, hello everybody. In this video we're going to look at a mock exam. So we're going to present it to you and make it, and hopefully it's useful for you. On the Teams you can also find the answers. So if you think I just want to check whether my answers are correct, just look at the PDF MATH2 mock exam answers. Okay, let's have a look at exercise 1. So we have two lines given, a line L and a line M. And the first question is to determine the coefficient matrix of this system. Well, first of all, we need to write it into the correct shape. So L would become 3x plus 3y equals 9. So the x up front, then the y. And M is already in the right shape, so 2x plus 4y equals 12. The coefficient matrix of the system is now just the things in front of the x and the y. So that would be 1, 3, 2, 4. So the answer to question A would be the coefficient matrix M of the system is 1, 3, 2, 4. Okay, and question B would be calculate the determinant, and then hopefully we remember that the determinant is the left diagonal minus the right diagonal. So if we would calculate it, determinant is given with those straight lines, so that would be 1 times 4 minus 2 times 3, so that would be 4 minus 6 would be minus 2. Okay, for question C and D, they want us to determine the intersection point of the two lines in two different ways. So once with the elimination method and once by using the inverse matrix. So let's start by doing the elimination method. So C, we put the two lines again underneath each other in the same shape. So x plus 3y equals 9 and 2x plus 4y equals 12. And then with the elimination method we need to get rid of one of the parameters as soon as possible. And then the obvious candidate would be x. If I multiply the first line with 2, then on both lines we have 2x. So let's do that. So multiply with 2 would give us 2x plus 6y being 18. And the other one we just copy. 2x plus 4y equals 12. Okay, now I can eliminate one of the two very easy by just subtracting them. So that would be 0 plus 2y would be 6. So that means now we have 2y being 6, so y being 3. Okay, then we use one of the lines to calculate the x. So let's do the first one. So x plus 3 times 3 equals 9. So that means x equals 0. So the intersection point we found would be 0, 3. Okay, and for question D, 1D, they want us to use the inverse matrix. So let's recap what we know about that. So the system is given with M times X being B. So let's write that with our values. So M would be 1, 2, 3, 4 times XY would become B, and B was the result value. So that would have been 9, 12. Okay, if we remember, then M times X being B, if we would multiply this with the inverse matrix on both sides, then the first part here would disappear. So that would give us X being M minus 1 times B. So if we can find the inverse matrix, then the only thing we need to do is multiply it with the result vector here of 9, 12, and then we would get the intersection point as well. So how did we calculate the inverse matrix? Then we first needed to do the determinant. So the inverse matrix was 1 divided by the determinant times the inverse matrix was the 1 and the 4 switch places, the 2 and the 3 stayed, but the values, the positive became negative and the negative became positive. So this would be the result. So from the previous part we remember that the determinant would be -2. So if we calculate the complete formula, that would give us, okay, let me go down a little bit, xy being 1 divided by -2 times 4 minus 3 minus 2, 1 times, and then 9, 12. So that would give us, let's leave this one for now, 4 times 9 minus 3 times 12. So that would be 36 minus 36, that would be 0. And then minus 2 times 9 minus 18 plus 12. So that would be minus 6. So in total that would give us 0, 3. Okay, so the conclusion would be, and I'll put it on the next little bit here on the corner, the intersection point is 0, 3. And that's exactly the same point we found in the previous elimination method. And so this is perfect. Exercise 2. So there are two vectors given, a vector A and a vector B. And the first question is, are these vectors perpendicular? Well, to find out whether vectors are perpendicular, we need to calculate the dot product. So 2 minus 3, 4, dot product 1 minus 4, 2. Okay, so that would give us 2 times 1 plus minus 3 times minus 4, so that would be plus 12, plus 4 times 2 is 8. So that is 22, so that's definitely not 0. So no, not perpendicular. And for the second part, question B, find a vector perpendicular to A and B. And then hopefully you remember you need to do the cross product. So 2 minus 3, 4, cross product, 1 minus 4, 2. Okay, so the first part would be the determinant, so the cross of the second and the third row. So that would be minus 6 minus minus 16, so that would be plus 16. So in total that would give us 10. On the second position I will just put the 2 and the 1, so the first row underneath, and then I can calculate the third and the fourth row. So 4 times 1 minus 4 would be 0. And for the last one we copy the second row, minus 3 minus 4, and do this last cross determinant. So that would be minus 8 minus minus 3, so that would be minus 5. So the a vector perpendicular to A and B would be 10, 0, minus 5. Well, if we have this vector, then the answer C is very simple. So we have to find a vector form of a line perpendicular to A and B that passes through a specific point. So we need to find a vector form, so x, y, z, perpendicular to A and B. Okay, we just found one, going to a specific point. So a specific point plus lambda times the vector we just found, 10, 0, minus 5. And let's simplify this one. So any division or multiplication of this factor would also work. So let's divide it by 5. Then we get 2, 0, minus 1. And that's the answer. So a vector form of a line perpendicular to A and B. Just use the cross product to find a vector perpendicular. We have a starting point given with this 1, 0, 1, and that's it. So for exercise 3, this one, we are given two vectors again, and what they want us to do is give a vector form of a plane parallel to the given vectors. Okay, this is just too easy, this question. And a lot of students who made this exercise really thought there was more to it. But please think, if it's a vector form of a plane to the vectors A and B, then we just need to rewrite the given information in a different shape. That's all there is to it. So x, y, z is a starting point. Well, there it's going to the origin. So that's 0, 0, 0. And you may omit this one if you like. Plus lambda times the first vector plus mu times the second vector. And that's it. So just rewrite what they gave you in information. The B part was a little bit more difficult. So to give a linear equation for a plane, we need to remember that the direction vector is perpendicular to the coefficient vector. And the coefficient vector we need to find the values in front of the x, y, and z in an equation. Okay, how can we find a coefficient vector? And then basically we've done that in exercise 2 already. We need to use the cross product of the two direction vectors. So the cross product of the two direction vectors would be, okay, first position. We use the second and the third row, so that would be minus 2, minus 6, that would be minus 8. Then for the second position, we put the first row beneath, so that would be 3 times 2, that would be 6, minus minus 1, so that would be plus 1, be 7. And for the third position, we write down 2, 2, so that would give us 2 minus 4 is minus 2. So this vector here can be used as the coefficient vector. So now we just need to write the equation. Minus 8 times x plus 7 times y minus 2 times z becomes a value. Well, to calculate this value we need to have a point on the plane. We've got one, because the origin is on the plane. So minus 8 times 0 plus 7 times 0 minus 2 times 0 would be 0. So the equation is this one, minus 8x plus 7y minus 2z being 0.